Good morning, students. I am your Nagini ma'am. Today I am going to discuss about the first year topic, students. Some basic concepts of chemistry. First lesson. Okay, first PUC chemistry students. First lesson. So first of all, I'm going to start with chemistry definition. Okay, what is the chemistry? Okay, students, what is the chemistry? And after that, we will enter into the topic, students. Clear this one? So first of all, what is chemistry? What is chemistry, students? It is a chemistry is the branch of science. It is the branch of science which studies about the which studies about the matter and its properties. Correct? So this is the definition of chemistry, students. What is the chemistry? It is the branch of science which studies about the matter and its properties. What is matter? So first we are going to discuss what is matter. Okay, what is matter? Matter is the one which has mass and occupies space, which has mass and volume. Clear? It is the one. It is the one which has mass and occupies space. Occupies space. It is called matter. Clear, students? That means the things which have both mass and volume. Occupying space is nothing but what, students? This is the volume. Clear this one? For example, this pen. See, students, it is the example of matter because it has some mass. Correct? It has mass and occupied some space. Suppose I kept on my hand. What happened, students? It is occupied. It occupied some space. Correct or not? This is nothing but volume. Clear this one? Occupying space, so it has mass, so that's why it is here. It is example of matter. Clear, students? Next one, matter. On the basis of physical state of the matter is classified into three types, students. What are the three types? Matter is classified into three types, students. What are the three types, students? So first of all, matter on the basis of physical state. Clear? Physical state. So on the basis of physical state, students, matter is classified into two types, students. What are the what are three types, students? What are the three types, students? First one is solids, next liquids, last gases. Clear? So on the basis of physical state, matter is classified into three types: solids, liquids, gases. Clear this one? Solids, liquids, gases. Now I'm going to discuss about the properties of solids, students. Okay, now? So what are the properties of solids? So first one, solids. Solids. So what properties we can discuss, students? Solids. In solids, the particles are held together very strongly and very closer to each other. Correct? The particles are very closer to each other, held together very strongly. Correct? So first point is the particles are held together very strongly and very close to each other. Okay, very close to each other. Understood, students? Very close to each other. So this is nothing but solids. Okay, Nama? So in the solids, what, students? The particles are held together very strongly and very closer to each other. Clear this one? Very closer to each other. And next point is if they want to move, all the particles in the solid should move together, correct? If they want to move, that means in the solids the particles, if they want to move, they have to move. That means complete all the particles in the solid should move together. For example, solid, see here, what is the packing will be there, how it is the packing. See students, in solids the particles are held together very strongly, means like this. Here see, these are the particles like this, okay, very closer to each other, understanding, held together very strongly and very closer to each other, understood Nana? So next point, if they want to move, all the particles in the solid should move together. That means in the solid here, what are the particles are there, if they want to move, they cannot move, students. That means here, if they want to move, all the particles in the solid should move together. That means if suppose this pen is there, okay, now it is the solid. Now I want to move this plate, this pen, from here to here. That means what happens, students, here? That means the particles are changing, that means the particles are moving. No students, here all the particles should move together. That means here, from here to here I am changing, means in these particles, what are the particles are there, all the particles should move together. Are you following? All the particles should move together. Clear students? What is the second point? If they want to move, if they want to move, all the particles should move together. Clear this one? All the particles should move together. Understood students? And solids have definite volume and they have the definite shape, correct? Solids have definite volume and they have definite shape Clear this students? Definite shape. So this is about the solids. Just some points I told, I'm discussing, students. The particles are held together very strongly and very closer to each other, because in between the particles in the solid, students, there is a strong intermolecular forces of attraction, students. If they want to move, all the particles should move together, okay. And next, solids have definite volume and definite shape. They have the definite volume and definite shape, correct or not? They have the definite volume. That means that the definite volume they have. That means if suppose it is having, it is occupied some space, correct or not, we can say it is at it has a definite volume. It is, and next it is having the definite shape. Yes, it is having the definite shape, correct. Solids have the definite shape, students, okay na? And next, fourth point, solids are incompressible, okay na? These are incompressible. Understood students? These are not compressible. Understood? Because there is no space between the particles. Here there is no space between the particles, so that's why these are incompressible. How much pressure applied also, we cannot compress the solids, students. Ardhaitama? So this is about the solids. Whatever the point, students, the particles are held together very strongly, very closer to each other. If they want to move, all the particles should move together. Solids have the definite volume and definite shape. These are incompressible. Okay students? See students, in liquids, what about the liquids, students? In liquids, the particles are held together strongly and closer to each other, but not as strongly as in solids. Are you understanding? So what is the first point, students? In liquids, the particles are held together strongly, okay, held together strongly and closer to each other, but not as strongly, okay, strongly as in solids. Clear this one? But not as strongly as in solids. Understanding, students? Okay now. So that is in the liquids. So here if you see the packing, students, in liquids, particles, how they are closer to each other. So that means there is a little gap between the particles, students. That's why, okay now, these liquids we can compress, less compressible, correct? See here, but not as strongly as in solids. Here also closer to each other, okay now, but not as strongly strongly as in solids. If you observe here, students, between the particles there is a little space. Okay, less gap is present. Understood? This is about the liquids. Now coming to the next point, liquids, Nana, liquids have definite volume, but they don't have the definite shape. Correct? So what is the second point, students? Liquids have definite volume. They have definite volume, students. They have definite volume. Okay, definite volume, but not the definite shape. Clear? They don't have definite shape, students. They don't have definite shape. Clear this one? They don't have definite shape. Understood, Amma? They don't have definite shape. And next, students, these are less compressible. Liquids are less compressible because there is a less gap. Correct? Less compressible. Understood this one? So these are the points of liquids. Understood, Nana? Now I'm going to discuss about the gases. What about gases, students? In gases, how the particles will be there? In gases, Nana, particles moves freely. Correct? There is no intermolecular forces of attractions. Understanding? Here, the particles moves freely. The particles moves freely, because here if you see the packing, students, how it will be, see here one particle, here like this. That means here there is no here there is no intermolecular forces of attractions. That means there is a more space between the particles. That's why they can move freely, students. In gases do not have the definite volume. Correct? They don't have definite volume and shape. Correct? They don't have the definite volume and shape. And next, they are highly compressible. What is the second point, students? They are highly compressible. Understanding? They are highly compressible because there is a more gap between the particles. So that's why these are highly compressible. When we are applying the pressure, automatically volume will be decreases. Are you understanding, students? That means whenever increase in the pressure, before the particles are very far to each other, okay, now they are moving away from each other, students, because there is no attractions. Whenever pressure is applied, what will happen? The gaseous molecules are come closer to each other. That means volume is decreases. That means that is nothing but compressible. Understood, Amma? So highly compressible. So these are the properties of solids, liquids and gases, students. Clear this one? Okay. Next, the three states of matter, students. Okay, now interconvertible. The three states of matter are interconvertible by changing the temperature and pressure, students. What are the three physical states of matter? Solids, liquids, gases. Correct? These three states of matters are interconvertible by changing the temperature and pressure, students. What I told, students? Three physical states. Three physical states of matter. Three physical states of matter or interconvertible. Clear? Interconvertible by changing the temperature and pressure. By changing temperature and pressure, students. By changing the temperature and pressure, the three physical states of matter or interconvertible. See, students, here I am taking solids. First of all, solids. Next, liquids, gases. See here, solids, liquids, gases. So by heating, I am taking like this. Here, this is, students, solids. So by heating solids, first of all heating, here I am taking heating. So that means solids by heating convert into liquid state. It is nothing but this process is called melting, students. What is this process? Melting. Okay, na? So this process is called melting. Okay. Next one. Now see, students, liquids by heating they can convert into gases. Understanding? So they can convert into gases by heating. So this is nothing but vaporization or evaporation. What we will call, students? Evaporation. Okay, evaporation, or we will call it as vaporization. Understood, Amma? It is also calling as vaporization. This process, that means solids convert into liquid by heating. This process is called melting. Understanding? Liquids convert into gases by heating. This process is called evaporation or vaporization. Next, gases by cooling convert into liquid, students. So that means here we are doing the cooling, students. See here, by cooling what will happen? Gas convert into liquid. This process is called condensation. What we will call, students? Condensation. Okay, this process is called condensation. Next, liquid by cooling it is convert into solid. This is cooling. Okay, by cooling liquid again it convert back into solid. Understood, Nana? By cooling. So this process is called freezing. What we will call? Freezing. This is called freezing or solidification. What we will call, students? Solidification. Okay, solidification. Next one, solids convert into gases. Okay, now solids convert into gases. Directly solid is convert into gas, students. This process is called sublimation. What we will call? If suppose solid is directly convert into gas, this process is called sublimation. What we will call? Sublimation. Understanding? This is called sublimation. If gas is directly convert into solid, if suppose gas, okay now, if suppose gas is directly convert into solid, gas convert into solid, okay, this process is called deposition. What we will call, students? Deposition. Okay, so this process name is deposition. Clear this one? So this process is called deposition. Once again, students, the three physical states of matter are interconvertible by changing temperature and pressure. So solids, liquids, gases. Solids convert into liquid by heating. This process is called melting. Liquids by heating they convert into gases. This process is called evaporation or vaporization. Next, gases by cooling convert into liquids. This process is called condensation. Are you following, students? This process is called condensation. Okay, and next one, liquids by cooling they can convert into solids. This process is called freezing or solidification. Are you understanding? Solidification. Next, if suppose solid is directly converted into gas, this process is called sublimation. Are you following? This is called sublimation. And next, gas if it is converted into solid, this process is called deposition. Okay, deposition. Okay, students, thank you very much, students. I hope you like this video. Please, if you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, students.